Hi guys, welcome to another section of differential equation series. So in this lesson, I will explain to you how to convert any differential equation into the standard form and differential form. Generally, the standard form for all differential equation is given as dy over dx is equal to a function of x of y. So you have your derivative on the left side and any function of x and y should be on the right side for the standard form. For every differential equation to be called standard form, this is how it should be. So as I said, your derivative on the left, then the function of x and y on the right. Let's come to differential form. Differential form is going to follow this order. You're going to have a function of x and y, then attached with the x, plus the function of x and y attached with the y should be equal to 0. So it's more of you separating the x differential parts and the y differential parts. Let's get to this example so you understand how to express them very well. I have a couple of examples here, so I'll express both in standard form and in differential form if possible. So let's see. The very first one, I have x prime. I have xy prime. So the very first one, x y prime minus y squared is equal to 0. To express this into the standard form, looking at what I have here at the standard form, I'll make sure that I leave this y prime on the left and send everything there. So that is exactly what I'll do. I'll have x y prime is equal to y squared. Then I also have y prime to be equal to y squared over x. Then I'm I'm done. Yes, I'm done. So my standard form for this is simply dy over dx is equal to y squared over x. So you can see that it follows the standard form. The y on the x on the left, then the function of x, y on the right here. Now the same problem, let's try and represent it in the differential form. So differential form df, what do? From the standard form, you only cross multiply. When I cross multiply, I'm going to get x dy should be equal to dx multiplying y squared. So when I cross multiply this section, you realize that I'm going to have x multiplying dy, then dx multiplying y squared. So as you see from the standard form, everything should be on the left should be equal to 0. So what do? I simply send the x component there. Then I'm going to have my differential form for this to be equal to y squared. Let me make it y squared dx minus x dy should be equal to 0. As simple as that. Now let's see the second problem. I have e to the power x multiplying y prime plus e to the power 2x multiplying y is equal to sine of x. To convert this into the standard form, the only thing we have to do is to leave this y prime here and send everything there, as simple as that. So I'll have e to the power x y prime should be equal to sine of x minus e to the power 2x multiplying y. At this point, I divide through by e to the power x. Then I'm going to have y prime to be equal to the expression sine of x minus e to the power 2x multiplying y over e to the power x. And this is the standard form because this is the same as dy over dx is equal to the expression. So this is the standard form. And whenever you get a standard form, you can easily get the differential form from the standard form. So differential form for this is simply equal to, I'll cross multiply my dy over the x, and I'm going to have e to the power x multiplying the dy. So e to the power x multiplying dy should be equal to, now you can see the x is here, will be multiplying whatever you have here. So I'll have the x multiplying sine of x minus e to the power 2x multiplying y. So let's see. So at this point, my differential form is simply going to give me, I have this here, I have this here, right? I only have to move one of them to the other side, okay? Any of them will be. So I can say that e to the power x dy minus the expression of sine of x minus e to the power 2x multiplying y, the x should be equal to 0. This is the differential form. This is the standard form, as you can see. Now let's move to the third one. For the third problem, is y prime plus y all to the power 5 is equal to sine of the expression y prime on x. This is to show you that not all equation can be expressed in the standard form as well as the differential form. So this equation here, you can obviously see we can't simplify it anyway. How do you go about this? There is prime, y prime derivative here, there is derivative here. So we can't express it into the standard form or differential form. Finally, we have this y multiplying y times y prime minus 1 is equal to x. So let's first express in the standard form. So I'll express in the SF. How do I do that? As I said, maintain the y prime at one side, then send everything. So I have my y prime minus 1 to be equal to x on y. First step, I'll have y prime is equal to x on y plus 1. Second step, then I make y prime the subject. I'm going to have 1 over y multiplying x on y plus 1. And this gives me my my standard form. My standard form, okay? So my standard form, y prime is equal to 1 on y multiplying x on y plus 1, okay? So now for me to express this in the differential form, what do I do? I simply have to cross multiply. So you know that this is the same as the y over the x should be equal to expressing or simplifying this. I'm going to have my, on my right side, this will multiply. So I have x on y squared plus 1 on y. So what do I do here? At this point, I only have to cross multiply, okay? So before I cross multiply, let's see we can do some simple simplification here, because the coefficient, sorry, the denominator here is quite not simplified. So I'll have the y over the x is equal to, my LCM is y squared. So I'll have x plus y goes here, y like this, right? So now it's simplified. So at this point, what do? I cross multiply to get y squared dy should be equal to the x multiplying x plus y. As simple as that. I only have to shift so that I get my y squared dy minus the x multiplying x plus y all equals 0. And this gives me my differential form. And that is all I have for you in this session. Thank you so much for joining. See you in the subsequent